All right, cylindrical shells here. So this is 7.3, number 33. So cylindrical shells aren't always necessary to use unless for some reason the washer method won't work. Even our Khan Academy video that I posted this morning says optional behind it for calculus AB, but sometimes it will be quicker than the washer method. And I'll show you why the washer method doesn't work here in a second. So if we rotate this one about the x-axis, the bottom shape would be down there somewhere, right? So I'd have the same thing down here. And then if I try to do my washer, all right, there's my washer, except when I try to solve this equation for y to do the washer method, it doesn't work. All right, so here's a case where we're going to have to use a cylindrical shell. All right, so for a cylindrical shell, instead of creating a washer, we're going to create a cylinder within this shape as we were rotating it around. So here's my cylinder, if you're following me here. Pictures aren't the best, so if you want a better example of a picture, page 402 in your book probably gives you a better example, or that Khan Academy video, they can draw that out a little bit better than I can. But if I have a cylinder that would be cut out of that 3D shape, all right, how do we find, I guess, the volume of each of these cylinders? Because I could stack cylinders on top of each other, an infinite number, to fit within this shape. Well, looking at it, the radius of my cylinder would just be some y value. All right, so my radius will be a y value. And then if I wanted to find the volume of the cylinder, now the cylinder has a big gap through the middle of it, right? If we can picture this is just a cylinder with a hole through the middle of it, right? So if I were to find the volume of that, I could take it and unfold it, right? And it would just be a giant prism, right? So to find the volume of that prism, we would have to find the circumference of our cylinder around the top, the outer circumference here. And then we'd multiply that by the height of our cylinder, which the height is just going to be equal to whatever our function is. All right. And then the width of these cylinders is going to be our dx or dy. In this case, it would be a dy. All right. So circumference right here will be equal to 2 pi, what did I say r was? R is equal to y. So 2 pi y is my circumference. And then my total outer surface area would be equal to my circumference times my height. All right, so my circumference times my height, surface area equals circumference, 2 pi y, times my height. So my height, I said, is just going to be my function, 12 y squared minus y cubed. All right, so now we're just going to find the volume using an integral of that surface area. The volume is equal to the integral, we'll do the interval in just a second, 2 pi y times 12 minus, or y squared minus y cubed, dy, so dy is the width of each of those cylinders. So now my interval is going to be from 0 to 1. If I look from 0 to 1, we're just looking at half of the cylinder here. All right. So now going down here, simplifying my integral. Let's see, we can pull out a 24 pi, 0 to 1. distribute my y, I get y cubed minus y to the fourth dy, which equals 24 pi. Let's find that antiderivative. 1/4 y to the fourth minus 1/5 y to the fifth from 0 to 1. I plug in 0, that doesn't do anything, so plug in 1, 24 pi, and I got 1/4 minus 1/5. 1/4 minus 1/5 would be 1/20th. So I get 24 pi over 20, which is equal to 6 pi over 5 for my volume. All right, so for part B, we're going to rotate about the line y equals 1 here, another horizontal line. All right, so we get a shape. Let's see. Something like this up here. So this part is the same. And then if I were to do my cylindrical shell within, let's go to 1 here, within this shape, all right, so there's my cylinder, correct? Now this time for my radius, all right? My radius this time would be 1 minus whatever this y value is, right? So my radius would be 1 minus y, all right? So in this case, the circumference is equal to 2 pi r, or 2 pi 1 minus y. I'm not going to distribute that right now because we'll be able to pull the 2 pi out in front of our integral. So then our volume will be equal to the integral of our circumference times the height of our function. So what is our function again? 12 y squared minus y cubed. The width of each of these shells is dy, all right? And our interval, again, says just half, right? We're looking at just half of our shell. And that Khan Academy gives a better example of why we're using half. Their pictures look a little bit better. So we're going from 0 to 1. All right, so let's go ahead and solve this integral. Volume is equal to, we can pull out a 24 pi, 0 to 1. All right, if I multiply these two, distributive property here, we get y to the fourth minus 2y cubed plus y squared dy. All right, so let's integrate 24 pi, let's see, 1/5 y to the fifth minus 1/2 y to the fourth plus 1/3 y cubed from 0 to 1. 0 doesn't work again, so I plug my 1 in. 24 pi. So I plug my 1 in. Let's see here. All of this in brackets will become 1/30th. So 24 pi over 30, divide the top and bottom by 6, 4 pi over 5. And then if you'd like to try parts C and D on your own, you can give them a shot, and I can check your work if you send it in, but it's not necessary to turn that in with your homework assignment. That's completely optional. If you want to practice this more, you can look at that Khan Academy video. It has some practice questions at the end. And then, like I said, this is kind of an optional topic for AP Calculus AB exam that we're taking. So if you would even happen to see anything on the exam, I think it'll only be one question, so don't freak out about this.